Hi everyone, welcome to another video in the CBM Flux Studio series. Today we will explore the work in progress around support for Vmax version 3. I'd like to start the video by having a look at what CryoFlux has done when converting a raw stream to a G64 for side 1 or side B of Afterburner. Let's have a look at what happened here, and specifically I'm interested in the right splices. So what I can do is to align all tracks to the right splices. Let's focus on the bottom part, and I would say let's go to this density area here. As you can see, what DDC has done has put the right splices before block 0, and you can see that in the tooltip. I'll just show it closer to where I am. Yeah, so for all tracks, the right splice, which is at the beginning now, has been moved at the beginning, is before block with block ID 0. Now what is also interesting is that for all the tracks there actually is a CBM header. Now the CBM header is a non-standard one for a couple of reasons really. One of the reasons is that the sector value in this CBM header is always 255, so all bits set in the decoded byte. Another difference is that off bytes are not standard, so they're not 0f in X, and yeah, there is always on all tracks there is always this CBM header, and CBM Flux Studio decodes it correctly, so it means the all 10 GCR bytes are here. Now I'd like to show, if we realign this slightly manually, so it's track 31 and it's I think 3 bits. Double check. Yeah, so now we have this track slightly realigned compared to where the right splice was, so that we have the right framing for the CBM header. Now 52 in hexadecimal is the first 8 bits of the GCR value of the block ID for CBM headers, which is 08 when decoded. But yeah, let's have a look at all the values here. So 52 7C AA D5 75. Okay, let's use the GCR decoder to actually decode what these GCR values are telling us. So 08 is the ID for CBM blocks, E0 is the checksum that is calculated over the payload, FF is the sector number, and 1F is the track number. We can go back here and do the other five values. So 75 was the last one for the first 5, then 9A, A6, A5, 49, 49. Okay, so again, let's just have a look at what they come down to. So 9A, A6, A5, 49, 49. 9A, A6, A5, 49, 49. So it's the ID bytes here ID2 and ID1, and then rather than the off bytes, there is this pattern here. Now this one is not included in the checksum calculation, but these two are, the two IDs and the track and sector are. So all these blocks pass the validation, otherwise we wouldn't see the information about the track and sector in the tooltip, which means that DTC has kept this block as a whole and has put the right splice slightly after it, which is good. I'm not quite sure whether this is really used by for any purpose by the loader code, but as you can see in event tracks, this additional CBM header is not there. Still there is this filter here. Now this very often this argument about Vmax not having block sinks and blah blah blah. I'm not quite sure where that argument comes from, because the block sinks are here. These would trigger the hardware. So yeah, there you go. Now I'd like to go to a nib file for this same disk, side B of Afterburner, and let's convert it to G64 and then align track data to Vmax V3. Now this is not finished, but I'd like to bring your attention to something quite interesting. Now this is pretty much what we already saw with DTC. Track 31, there is a CBM header here, and it's the very same values, AA, D5 and then 75. Yeah. So on all tracks, it's true, there is this CBM header here. I think we can ballpark where the right splice is. You know, it appears is here. So the track ended actually with writing this header, CBM header, and here, well, it's here, but by comparing these tracks, you know, side to side, it appears that the right splice for event tracks is here, and that's just based on, you know, the disruption on, you know, the regularity of this pattern before and after here. So it seems like it overlapped here. Again, it's not something that I would say quote me on this one, but if we look at what DTC does, if we look at this disruption here, if we look at this CBM sector here, it appears that this CBM sector on all tracks is the last thing written, and as you know, just as a speculation, I think comparing tracks side to side, it appears that the last block is written last on event tracks. And that was it for this video. In the future, I'll make sure I'll get these block sinks at the beginning of the track as well, possibly some of the padding, and do bright splicing, or you know, at this point in the stream. But yeah, that's some development for the future. I hope you enjoyed the video. Thanks for watching, and see you in the next one.